So the founder of Anthropic, one of the leading AI companies in the world, just shared their internal framework for building AI agents. And in this video, I'm breaking down the 3 principles that he shares that could completely change how you approach building AI agents. So the first one, why you shouldn't build AI agents for everything. Second, how to keep your agent development simple. And third, the crucial mindset for thinking like your agent. So whether you're just starting out or deep in development, these principles will help you build more effective AI agents. So let's head over to my laptop, take a look at the clips from the conference, and give you some actionable insights that you can take away and implement today. Let's go. So before we get started on the first principle, I just want to shout out AI Engineer who shared this conference recording online from their conference. So I'll put their links to the YouTube channel and to the full recording if you want to watch the whole talk. It's about 15 minutes long. I've just cut out a few sections here that we're going to highlight in this video. So let's get started with principle number 1, why you shouldn't build agents for everything.
Don't build agents for everything. Well, why not? We think of agents as a way to scale complex and valuable tasks. They shouldn't be a drop-in upgrade for every use case. If you have read the blog post, you'll know that we talked a lot about workflows. And that's because we really like them, and they're a great, concrete way to deliver values today. Well, so when should you build an agent?
Okay, so it's important to note he's talking about workflows as a vehicle for delivering value, which is what I talk about a lot on this channel. So let's see what kind of checklist he has for when to actually build an agent.
Here's our checklist. The first thing to consider is the complexity of your task. Agents really thrive in ambiguous problem spaces, and if you can map out the entire decision tree pretty easily, just build that explicitly and then optimize every node of that decision tree. It's a lot more cost-effective, and it's going to give you a lot more control. Next thing to consider is the value of your task. That exploration I just mentioned is going to cost you a lot of tokens. So the task really needs to justify the cost. If your budget per task is around 10 cents, for example, you're building a high-volume customer support system, that only affords you 30 to 50,000 tokens. In that case, just use a workflow to solve the most common scenarios, and you're able to capture the majority of the values from there.
So I think the key takeaway here is that we don't need to build an AI agent for absolutely everything. Like, simple workflows are great. So we need to look at the complexity of the process you're trying to automate, the value of the process, and also the cost of the tokens. So let's look at an example that he goes through here of when an agent actually makes sense.
Let's see this checklist in action. Why is coding a great agent use case? First, to go from design doc to a PR is obviously a very ambiguous and very complex task. And second, a lot of us are developers here, so we know that good code has a lot of value. And third, many of us already use Cloud for coding, so we know that it's great at many parts of the coding workflow. And last, coding has this really nice property where the output is easily verifiable through unit tests and CI. And that's probably why we're seeing so many creative and successful coding agents right now.
So the coding example that he just showed was a great use case for an AI agent, right? Complex task, definable value, and a specific output. So let's go ahead, dive into principle 2, keep it simple.
Once you find a good use case for agents, this is the second core idea, which is to keep it as simple as possible. Let me show you what I mean. This is what agents look like to us. They're models using tools in a loop. And in this frame, 3 components define what an agent really looks like. First is the environment. This is the system that the agent is operating in. Then we have a set of tools, which offer an interface for the agent to take action and get feedback. Then we have the system prompt, which defines the goals, the constraints, and the ideal behavior for the agent to actually work in this environment. Then the model gets called in a loop, and that's agents. We have learned the hard way to keep this simple because any complexity up front is really going to kill iteration speed.
So it's really interesting how he's kept this super simple. Environment, tools, and system prompt. Those are the building blocks of your AI agent. Now let's So let's see why this works and how to implement this framework.
Iterating on just these three basic components is going to give you by far the highest ROI, and optimizations can come later. Here are examples of 3 agent use cases that we have built for ourselves or our customers, just to make it more concrete. They're going to look very different on the product surface. They're going to look very different in their scope. They're going to look different in their capability. But they share almost exactly the same backbone. They actually share almost the exact same code. The environment largely depends on your use case. So really, the only 2 design decisions is what are the set of tools you want to offer to the agent, and what is the prompt that you want to instruct your agent to follow.
Now, you mentioned a really common startup meme, which is complexity kills iteration. And that's true when you're building AI agents. If you're trying to start off in a really complex place, then you're going to bump into a bunch of errors and end up spending most of your time troubleshooting. And I've been there myself, where I've tried to build this complex workflow and nothing just seems to work. So starting simple, mapping out your process step by step, and understanding what happens at each step is going to be critical before you actually dig into the tech and build it out in your platform of choice. So let's get into principle number 3. And I think this is the most unique. I've not heard anybody talk about this, and it's thinking like your agents. Let's go.
Right, this is the last idea, is to think like your agents. I've seen a lot of builders, and myself included, who develop agents from our own perspectives and get confused when the agents make a mistake. It seems counterintuitive to us. And that's why we always recommend to put yourself in the agent's context window. Agents can exhibit some really sophisticated behavior. It could look incredibly complex. But at each step, what the model is doing is still just running inference on a very limited set of contexts. Everything that the model knows about the current state of the world is going to be explained in that 10 to 20K tokens. And it's really helpful to limit ourselves in that context and see if it's actually sufficient and coherent. This will give you a much better understanding of how agents see the world, and then kind of bridge the gap between our understanding and theirs.
So he makes a great point here, experimenting with limiting your context window, because often when we build an AI agent, we can overload it with too much context and too many instructions. So what he's saying here is to experiment with limiting that context window and monitoring so you get the desired output for the minimal amount of context. It's basically like creating a SaaS, an MVP. What is the minimum prompt and context window that you can give that agent that's going to get you the desirable result that you want? So let's look at an example.
Let's imagine for a second that we're computer use agents now, and then see what that feels like. All we're going to get is a static screenshot and a very poorly written description. This is by yours truly. Let's read through it. You're a computer use agent, you have a set of tools, and you have a task. Terrible. We can think and talk and reason all we want, but the only thing that's going to take effect in the environment are our tools. So we attempt a click without really seeing what's happening, and while the inference is happening, while the tool execution is happening, this is basically equivalent to us closing our eyes for 3 to 5 seconds and using the computer in the dark. Then you open up your eyes and you see another screenshot. Whatever you did could have worked, or you could have shut down the computer. You just don't know. This is a huge leap of faith. And the cycle kind of starts again. I highly recommend just try doing a full task from the agent's perspective like this. I promise you it's a fascinating and only mildly uncomfortable experience.
So you can see the prompt that he created for the agent is very limited, and it doesn't really give much context or detail. So let's see how Barry is actually going to change that prompt and start to think from the agent's perspective.
However, once you go through that mildly uncomfortable experience, I think it becomes very clear what the agents would have actually needed. It's clearly very crucial to know what the screen resolution is, so I know how to click. It's also good to have recommended actions and limitations, just so that we can put some guardrails around what we should be exploring, and we can avoid unnecessary exploration. These are just some examples, and do this exercise for your own agent use case and figure out what kind of context do you actually want to provide for the agent. Fortunately, though, we are building systems that speak our language. So we could just ask Claude to understand Claude. You can throw in your system prompt and ask, well, is any of this instruction ambiguous? Does it make sense to you? Are you able to follow this? You can throw in a tool description and see whether the agent knows how to use the tool. You can see if it wants more parameter, fewer parameter. And one thing that we do quite frequently is we throw the entire agent's trajectory into Cloud and just ask it, hey, why do you think we made this decision right here? And is there anything that we can do to help you make better decisions? This shouldn't replace your own understanding of the context, but it will help you gain a much closer perspective on how the agent is seeing the world. So once again, think like your agent as you're iterating.
So this is really interesting. He's given 3 sort of buckets of context to give the agent. One, the environmental context. So in this case, the size of the screen and specifically what to do. He's given recommended actions, so what the agent can execute on, and then also limitations, what it shouldn't be doing. So this is really cool. Highly recommend you think like this before building another AI agent. And so this example really drives home how limited an AI agent's perspective can be. They're working with static snapshots and limited context. So we need to think from that perspective of how they see the world and adjust our prompts and context windows appropriately. So one final clip here from Barry about the future of AI agents. Let's go.
Next up is this concept of self-evolving tools. I've already hinted at this 2 slides ago, but we are already using models to help iterate on the tool description. But this should generalize pretty well into a meta tool, where agents can design and improve their own tool ergonomics. This will make agents a lot more general purpose, as they can adopt the tools that they need for each use case. Finally, I don't even think this is a hot take anymore. I have a personal conviction that we'll see a lot more multi-agent collaborations in production by the end of this year.
So yeah, a little hint there at the end, multi-agent collaboration, that's going to be a big thing as we move towards the end of this year and early next year. And as we can see, the future of AI agents is evolving rapidly. But the core principles that Barry has just outlined in this video will remain crucial for successful implementation. Okay, so let's break these principles down into some actionable insights. So first, evaluating your use case. Is your task genuinely complex? Does it justify the token cost? And can you verify the outputs? So you want to go through this checklist before you build an AI agent for some kind of process you're looking to automate. So a checklist for building your AI agent. So focus on these 3 core components. Define your environment, select essential tools, and craft a clear system prompt, like you saw in the examples in this video. And third, testing and iteration. So use Claude itself to evaluate your agent. First, test your prompts for ambiguity. Second, analyze your decision points. And third, gather feedback on the tool usage. So if you're building AI agents or you're just planning to get started, then make sure you hit subscribe and like on this video so more people get to see this video and hear from the horse's mouth, Barry over at Anthropic, how to actually build AI agents right now. So drop me a comment below, let me know your biggest challenge with building agents. And with that being said, my name's Tom and I'll catch you in the next video.